All right, and last but not least, we have our level 4 practice, which is kind of a big deal. It really shows your understanding of exponential functions, linear functions here. It is a good practice to get to level 4. If you're able to do level 4, it really shows that you have that deep understanding, like I was saying. So I did kind of start this already. Here, level 4 practice. This is on page 10, lesson 3, level 4 practice. Write a reasonable scenario to match the following equations. Now, reasonable, right? So I just have a little, I wrote down something here, and you're going to have more room. I ran out of room. Here we have an exponential function, growth rate of 2, starts with 5. It could be something like, hey, we have 5 bunnies in our yard, and each month they double, right? So after how many months will you have either a certain amount of bunnies, or after 12 months, how many bunnies you're going to have? So there's a reasonable scenario for that one. Next one, it's a percentage exponential function. It could be something like, and you can write this out. I don't have any room, but I can explain it. You have $500 that your grandpa gives you, for graduating high school, and then every month, you got a really rich grandpa, $500, oops, I didn't mean to put that in parentheses. Let's cross that out. $500. Let's just say every month he gives you a 25% increase. And that's going to be a lot of money here pretty soon. Reasonable? Maybe. So since it's a 25% increase, that's going to be 0.25 there for my growth rate. We can figure out how much money you're going to have, if this is the case per month after like a year. Actually, I'm kind of curious. I didn't figure this out. If your grandpa gives you $500 and he gives you each month a 25% increase, let's see how much it's going to be after 12 months. So we would put in 12 into the x. I'm actually really curious. 1.25 is my growth rate because it's an additional 25%. Hit my exponent button, hit 12. Multiply that by 500. Holy crap. There you go. If you have a super rich uncle or a grandpa that really loves you, or whoever gives you $500 and then gives you a 25% increase per year, that is $7,200 and basically $76. You went from 500 to 72.75 in just a year. That is amazing growth right there. I wish that could happen to me. That'd be awesome. All right, letter C. We've done a lot of fair questions before. This is a linear function. 20 is my y-intercept, so it could be something that, hey, $20 to get into the fair and then $3 per ride. So you can write that out. $20 to get in, and the reason why this is linear is that that linear constant, the $3 per ride. When you see per, that's slope. And then finally, letter D, you bought a car for $40,000. That's the initial amount, and then each year it depreciates or decays at 12% each year. And so this is a 0.88. So obviously it's decreasing at 12% because that's coming down from 1. That's our 1 minus our percentage that we were talking about earlier. So let's just say after 3 years, let's see how much it's worth. 0.88 raised to the third power, multiply that by 40,000. After 3 years, not terrible, your car is worth $27,258. That's not too bad. Okay, so that's how you would write a reasonable scenario for those. And for here, we are just writing exponential equations based on our graphs. So here, they're all exponential, so I have y equals 60 is my starting point. So now what do I have to do is I have to take one of my y values, it doesn't matter which one, and divide it by the one before it. All right, so let's take 43.8. That seems like it's going to be pretty easy. 43.8 divided by 60. We are going to get a decimal number, and that's okay. So 0.73. So my growth rate is 0.73, and then my x. Right? What that means is each of my y values as now I'm going is decaying by 0.73, and that makes sense because it's decreasing less than 1 growth rate. The next one here, y equals, what's my y-intercept of 8? So I'm going to put 8 right there. What's my growth rate? Well, I just take one y value, doesn't matter which one, and divide it by the one immediately before it. So I'm going to do the 1, 10.4, so I just need the 10.4. So 10.4 divided by 8, that gives me 1.3. So that's 1.3 is my growth rate. Makes sense. It's increasing. It's above 1, and my graph is going up. All right, last one. My graph is going down, so I know it's going to be less than 1. I have y equals, I have 7 as my y-intercept. That's my starting point. And, same thing like I did. I'm going to take one y value. It could be any one, 7 in this case. Divide it by the 1 immediately before it. And I know it's immediately because it goes from the 0 to the negative 1. So 0 to negative 1, good. So I'm doing 7, that's my y value right there, divided by 12.5. And my growth rate is 0.56. Now I do want to show you that it doesn't matter which y value we start with, right? Let's look at this 3.92, right? If we divide it by the y value immediately before it, are we going to get the same thing? Well, let's check. 3.92, this y value, divided by 7, which is the y value before it. Oh, sweet. Yep, 0.56. Don't forget your little x. All right, that was the level 4 practice from lesson 3.